So here's our free fall apparatus. It's about 100 years old, thereabouts, and it works very fine. So it consists of two wires, spaced, they're vertical wires, spaced basically just a little bit farther apart than this little distance here. This is a metal collar on this freely falling object, which isn't freely falling at the moment, but will be. And I've got about 1 meter length of tape here, taped directly in front of the center of the back wire. So this power supply down here is going to generate a spark that's between 20 and 30,000 volts, which is a spark that will easily jump not from this wire to this wire directly. That would take more like 50,000 volts. But it can jump the little distance between this metal ring, which is 1 millimeter or so, and the metal ring in the back, which is 1 millimeter or so in front of the back wire. So if it jumps a couple millimeters instead of 50 millimeters. And so it can do that. So what happens is when I push the button, this electromagnet will be turned off. When I push this button here, the electromagnet will be turned off and the object will fall. And when I push this red button here, the spark will be produced every 60th of a second. So every 60th of a second, the spark will jump from this wire to the back wire, run around this ring and through this piece of paper, which is in which there's going to be burn a little hole, and there's a coating in there which will make that hole big enough to see. So we'll have little black dots everywhere this ring was every 60th of a second as it falls from up here to down there. Freely falling body. It's just very, very simple, very nice apparatus. So right now the electromagnet is on. So it's going to hold that object up, and I'm going to let that sit a minute so it stops swinging, because if it swings a millimeter over, it's going to rub these wires, and if it rubs the wires, you will see a kind of faint stripe down the pattern, and that means it's rubbed the wire, which means you shouldn't use that pattern because it's slowed down. It's not a freely falling body. So I'm going to check the pattern and see if make sure there's not a stripe on it where it's rubbed against that. What we're going to do this year, just to keep distances, we're going to, instead of everybody crowd around and see this, we're going to show you this on the video, and then we're going to have tapes ready for you to analyze. So this is pretty simple. I'm going to stand over here, and the key thing is, since you're not going to do this, it's not going to bother you, but don't be made nervous by sparks jumping. But you have to start the sparks jumping before you let the free fall object go, and you have to keep the sparks jumping until it gets past that point there. So here's the spark. You can see it up there, and we will let that go and then push the button to release the freely falling body. And that's it. Again, it takes about 4/10 of a second for something to fall from 0 vertical velocity to a meter below that, and the experiment's over. So this experiment is done in something under half a second. So let's take a look at the back side of this tape. And you probably can't see this on the camera. But there are dots, and unfortunately there are also vertical scrape marks on this. So I can't use this to analyze because it's obviously not totally freely falling body. There's a scrape mark here, there's a scrape mark here, and there's actually one here. So I have not lined this up vertically exactly. It's pretty sensitive. I will have to do a better job of lining it before we give you the strips for yourself. But we can at least take this over to the lab that you're in and show you how to do the measurements. So let's do that. Okay, so we've stretched out the 1 meter long tape, and I'm just going to show you 4 points as an example. I carefully put the meter stick vertically right next to those dots so that the lines on the meter stick are as close to the dots as possible, so there's no parallax problem. And I'll read, for instance, you can look at these at your leisure to see if you agree with me, but the last point, the last number is going to be somewhat debatable, which is, of course, what the last significant number should be. So I get for these 4 points 21.62, 24.92, 28.44, and 32.22. Again, you may debate with me on that last number, but I think you won't be too far from what I suggested. So that's reading the meter stick to the nearest hundredth of a centimeter or tenth of a millimeter, which is pushing it all the way to its limit. That's what we always try to do in the lab, is if you don't know whether the numbers you're getting are critical numbers in terms of error analysis or not, then you want to read every instrument as well as you can. And when we have these dots here laid out, you can look at the center of the dot and where that is on the meter stick and get numbers like I got.